Hello everyone. All right, in this video, I'm going to go over the precise definitions of limit part one. All right, so earlier we saw the definition of a limit. That's what the definition of a limit here. So let me recap what we did. So suppose the function f is defined for all x near a except possibly at a. So if f of x is arbitrarily close to L for all x sufficiently close but not equal to A, we write the limit of f of x as x approaches A equals L. And we say that the limit of f of x as x approaches A equals L. All right, so but in here, the objective of this section is to crystal clear what the close or approaches um, the mean in mathematics. So how can we express the close to L or approaches A mathematically? So to figure out that, so we wanna see the just simple the example. This is the piecewise function, right? So but by the way, before going further, I I'm pretty sure that you already know this one, but in this limit, the value of f of x depends upon the value of f near a, but it does not depend on the value of f of a. Okay, so probably, I mean, depending on the problems, or in some cases, the limit of f of x as x approaches a equals f of a, but it's not true. It's not always true, right? So all right, so back to the here, this function f of x is defined by 2x minus 1 if x is not equal to 3, and then if what if x is 3, then f of x defined by 6. So the graph of the that function is like this. So 2x minus 1 is definitely this is a straight function, so like this, but there is the open disk right there, because when x equals 3, then f of 3 is defined by 6. So the f of 3 is 6 right here. We say we have see the dot right here. So it's clear that limit of f of x as x approaches 3 is what? 5. Yeah, so but we want to the develop the establish the mathematical expression of the close, the word close or approach, right? So to do that, first, let me start off this question. So how close to 3 does x have to be so that f of x differs from 5 by less than 0.1? So the first we want to here we want to just specifically we want to just find out uh, just the number of x so that the f distance between f of x and 5 is less than 0.1. Okay, so now then to figure out that, let's take a look at that graph. So now this epsilon represent the 0.1, which is the distance, the far away from the 5. Okay, the value of the I mean distance of the f of x just from the 5, and the delta represent the distance of x, um, the far away from the 3. Okay, so we just see it when epsilon is a 0.1. If we choose delta is a 0.5, which means that x can be any number between the vertical, red line, and then this is the purple kind of purple, the vertical red line. So then as you can see that if x is, for example, this is 2.9. If x is 2.9, then f of 2.9 is a 4.8. I don't think a 4.8 is a 4.8, and distance between 4.8 and 5.1 is 0.1, actually 0.2, right? So that e number doesn't satisfy this one, epsilon 0.1. I mean, the f of x not gonna be not gonna differ from 5 by less than 0.1. So then what if delta is 0.1? So x is close, this much close to 3.1, then the as you can see that if x is the, for example, 3.05 right there. Oh, sorry, I put just between 3.05 and 3.1, then the function value will be kind of probably 5.15, something like this. So still that's the outside of the you know the distance between a 5 and a 5.1, right? So then the delta must be less than 0.1, definitely. So then what if delta is 0.05? Then you see that every single the value between here, x value, their function value is between here and here, okay, within that two horizontal line. So the distance between function value and 5 must be less than 0.1. Okay, so delta must be 0.05, right? So for every single every single epsilon value, I mean, for arbitrarily for any the value of epsilon, as you can see that here, we can find out the appropriate delta, the value of delta, so that the f of x, distance between f of x and the 5 is within epsilon, right? So here, so now from here, we want to get the idea how to express the limit in terms of an epsilon and delta. Okay, let's look at this. So expressing the limit, I mean that what we saw, what we figured out for that question, how close to 3 does x have to be so that f of x differs from the 5 by less than 0.1? Then it means that we want to find out number delta such that f of x is within that interval 5 minus 0.1 and 5 plus 0.1 whenever x belong to that interval 3 minus delta and 3 plus delta, but x is not equal to 3 definitely. So then but for any the interval we could express, I mean that interval is kind of symmetric, right? So the we could express that interval in terms of absolute value. So f of x minus 5, absolute value of f of x minus 5 is less than 0.1. That's the that expression is equivalent to that expression. And then so this is symmetric. So absolute value of x minus 3 is less than delta. Okay. So if absolute value of x minus 3 is less than delta, then absolute value of f of x minus 5 is less than 0.1. So now here, that 0.1, so we just specifically just pick a number 0.1, right? But we want to just what if we arbitrarily choose that number? Okay, then what happened to delta? So then here, then you make a sense that oh, then delta must depend on the that value, right? So yeah, finally we want to get the some kind of expression, I mean algebraic expression for delta in terms of the epsilon eventually. Okay, so that's what we're gonna do next the video. Okay, so let's see the next video.